Ladies and gentlemen, boys and girls, if you're hanging out in the hallway, you're going to want to make your way in. We've got Dr. Sarang Noether, who's going to be talking with us about ring signatures from the looks of the title. It's this guy right here. He's a pimp. Look at his gold little thing right you got going on there. He's got some sort of vibe. You guys aren't on top of the stage here with me. You can't feel this vibe. It's really, really polarizing. I want to leave the stage so that way he can give all of his knowledge to us. So please, if you're out in the hall, go ahead and come on in. For those of you that are still talking, I would very kindly request you to either lower the volume a little bit and or take the conversations outside to be respectful to the people that are going to be listening to this talk. Sarang, you've got a full house, man, so you knock it out of the park, man.
Hello, everyone. Thank you for coming to the last talk. You're respecting my time by being here. I respect your time by trying to go a little bit early. Because I'm very... this conference is fantastic, but also exhausting. So I am a mathematician and researcher, and I am particularly interested in kind of the formalization and efficiency of our transaction protocols and those of other projects as well. So today I will be talking about transaction protocols. The title was merely a ruse to excite people to get them into the talk because it sounds exciting. But I'm actually going to talk about transaction protocols. But fortunately, it will not be very technical. And the goal of this talk really is to kind of give people a sense of what goes into blockchain-based transactions. How does efficiency work on them? And how can we improve it over time, since that's always a goal. So kind of a brief outline of some options that are available that Monero and other projects too might consider going to, and why they might or might not at this time. So briefly, people often say that Monero as a digital asset is CryptoNote based. CryptoNote being kind of the original transaction protocol that kind of inspired Monero and a whole bunch of other assets. And it's based on that, but it's not strictly true that Monero is a CryptoNote asset anymore. So I just like to say that it uses the Monero protocol. So the transaction protocol basically dictates the structure of transactions. So what goes into them, what goes out of them, what math is used to verify that everything is completely kosher with a transaction in terms of balance and ownership of assets and things like that. So we've definitely moved past as a project the CryptoNote protocol, but most of the basic structure is still there. So some big ideas behind it. I actually don't like some of the terminology that is used a lot. The word output gets thrown out a lot, especially in like Bitcoin-based digital assets. I don't really like that term. I think it doesn't tell you a lot because outputs become inputs, become outputs. So I'm going to use the phrase notes, which is something that I really like, almost kind of like a banknote, you can think about it. But basically, funds exist in like these notes or outputs that exist on the chain. And notes in Monero, at least, using the Monero protocol, are not just recipient addresses. They're actually derived from recipient addresses in a one-time use kind of situation. The amounts of transactions are not visible in the Monero protocol, but they're in fact hidden in something called a Peterson commitment, which is can kind of think about it as kind of an algebraic one-way hash where algebra works nicely enough that we can show that transactions balance, which is important. I need to make sure that funds going in a transaction are the same as funds going out. And in particular, the spends themselves are done in the Monero protocol, unlike, for example, Bitcoin and its derivatives, using a specified anonymity set of previous other arbitrary notes. So the Monero protocol does not mix funds. In the Monero protocol, a particular note would be spent in a transaction, but it is basically obscured among other notes that exist on the chain that are chosen non-interactively. So a little bit different. So a transaction basically spends a set of one or more input notes, each of which has its own anonymity set, and it generates a new set of output notes. So transactions consume notes and generate new ones. That's the idea. The idea of like an account in Bitcoin or Monero, it doesn't really exist in the protocol level. It's just kind of a nice bookkeeping abstraction that we use to tell you like what your funds are. So what do we mean by transaction efficiency? We care a lot about that. Well, we actually care about it in terms of kind of not just space or time, but kind of space-time in a physics sense. So space means, of course, that transactions take up space on the chain, and provided that everyone using the protocol is going to be doing something with the chain to verify it, that space basically ends up kind of coming along for all time. Transactions also have a generation time and a verification time, and it's important to keep those two separate. So transaction generation time is, I want to spend some funds on the chain, so how long does it take for whatever the protocol says needs to be done mathematically to be done? And in general, that time is typically allowed to be long by cryptographic standards. So we don't want it to be too long. I mean, initially Zcash, for example, ran into a problem where transaction generation took a long time to do, on the order of maybe 10 or 20 seconds. My personal perspective, if your transaction generation time is on the order of like a second even, that's pretty good. The average user is not going to notice that that feels like a long time. But verification time is something that we do care a lot about, because if you're basically validating the entire chain of transactions, you need to operate on each individual one. Even if a particular transaction takes 100 milliseconds to verify, if you have to do that 10 million times, well, that's a long time. However, in some transaction protocols, we can do something called batching, which is kind of cool. Monero currently doesn't do this with its full transaction protocol, but the idea is that in some protocols, you can take a bunch of transactions and operate and verify them all at once in a way that's much faster than doing them independently and linearly. The trouble, of course, as I said, is that transactions take up space-time, and in particular, every input note to a transaction has a particular anonymity set. And it also has to have an authorizing signature showing that it is intended to be spent in a transaction. Output notes that are generated, they have a host of other data, kind of auxiliary data that are associated with them that are needed for proper verification. And of course, signatures and all the proofs and everything that we're packing into this big transaction structure have to be verified by the network, so time comes into play. So ideally what we'd want to do from a privacy perspective in these projects and assets is increase anonymity. Well, in some sense, that's an easy parameter to change. In Monero, we have a parameter called the ring size, which is how large is the anonymity set of every spent note. And in theory, that's just a network parameter that we could change in the code at any time. But the trade-off is space-time. If we were to increase that hugely, you'd end up taking up a lot more space for each transaction, and generation and verification would become very unwieldy. So you can't get everything you want for free. So let's look at several big ideas that have been floating around. I often get asked like, oh, I see all these things, in the news, whatever that means for you in the crypto sense. But I'm not really sure what they are, how they interact, why we are or are not using these. So let's go through them alphabetically. So one of them is called CLSAG. That was partially developed in-house along with some other folks. Random Run was the one who came up with it. DLSAG is one that we've been working on with Pedro Moreno Sanchez and other collaborators, and several others that came from elsewhere, Lelantis, OmniRing, and Ring CT3. So each of them takes a much different approach toward better scaling with improved anonymity, ideally. But there's different sets of trade-offs. So this is not going to be a comprehensive dive into any of these, but just a basic overview of like what's available as a potential future for digital assets like Monero. So keep in mind, like I had said, the way that Monero's ring signatures currently work is that you have this signature structure that does some cryptographic magic. What goes into it are the input notes, a true spend, and a bunch of decoys that are just kind of thrown around. Some additional hidden amount data goes in, and what also pops out is what's called a tag. And the tag is basically used to detect double spending. Because remember, there's some kind of obscurity from the spending going on here. So if two transactions popped out the same tag, you'd be able to detect a double spend. So the whole signature operation has to prove that you own a note that you're spending. It has to assert that the transaction balances in a hidden way, and it must prevent double spending. And in our current case, a transaction may actually have several signatures if I'm spending several input notes. This is why the scaling gets pretty bad sometimes. But a modification of our current signature scheme, this modification is called CLSAG, and there's a longer name for it that I'm not even going to bother saying. It basically does the same kind of ring signature stuff that we do right now. But the benefit is that through some clever compression that this guy Random Run came up with that we worked on, it basically ends up meaning that the transaction and the signature end up being much smaller on the chain. The signature size drops by about half, which is fantastic. And it's faster to verify, not quite by the same amount, but still faster to verify and in fact to generate. So you basically get all of this stuff for free. The downside is it only works for reasonable anonymity set sizes. Right now, Monero's anonymity set size is 11, so basically any spend, absent external information, spends 1 out of 11 notes. And you really can't increase that much with this scheme. So we really couldn't increase the anonymity very much. We could do it marginally without any added cost in space and time. The benefit, though, is we do have formal security proofs for it, and that means that it's essentially a faster and smaller drop-in replacement for the current ring signature scheme with provable security, which is frankly pretty tough to do sometimes. No real downsides. And the status right now, we have a preprint paper available for this. Hopefully going to be getting it peer-reviewed and audited. We've had some folks looking at it, which is a good start. And in fact, code is ready to go for this. So this is something we'd like to deploy. Another new signature scheme called DLSAG actually changes the structure of Monero's outputs and the ring signature in not huge ways, but enough ways to make it a little bit more challenging. The benefit to this scheme is that besides kind of showing all the other stuff that we like balance and things like this, it could also enable such things as refund transactions non-interactively. There's some stuff involving payment channel networks that we could enable, and very limited kinds of atomic swaps that depend very heavily on like curve choice and stuff. But the downside to that is the way the scheme is set up right now is it would enable a particular kind of tracing where you could detect when certain spends occur. And this would mean that effectively you'd have to, if you receive funds, you'd have to spend them to yourself in order to break that linkage. And the downside is from scaling, you really couldn't do anything to increase anonymity for free. So you'd effectively open the door to things like off-chain functionality, which is pretty great, but at some cost involving self-spending and certain kinds of migrating output pools. That's a little bit tricky. However, a preprint is available, and we're just kind of hoping that there may be a solution to the tracing problem involved with that to enable this cool functionality that we like. Another one, and the authors to this paper are actually here in the village at some point, I think somewhere. But it's a protocol called Atlantis. And this is actually based on the Zerocoin protocol that's been used in other assets. And this was designed by and for the Zcoin asset, in fact. But the paper is publicly available. It uses a very, very different kind of authorizing spend proof than Monero uses right now and that we may consider moving to. It turns out there's another auxiliary proof that you need besides the spend proof, called the range proof, that we could actually reuse existing fairly efficient code that we already have. I personally like Atlantis because the spend proofs become very, very small and efficient, even at an extremely large anonymity set size. We're talking on the order of 100 or 1,000 notes instead of around the order of 10 notes. But the downside is, similar to DLSEG, it requires a self-spend operation to avoid someone being able to detect when a spend has occurred. There's a limited amount of information that's leaked there, but it's still leaked. So effectively, you'd get pretty high anonymity sets, you get very efficient proofs, but at the cost of this whole self-spend operation. But it's very promising, and I think it's actually a really clever approach. I know Zcoin has some code in progress, and we on the Monero side have also been working on some prototyping code just to kind of test it out. Another one that came out very recently is called OmniRing. And this was actually designed kind of with Monero in mind, as far as I know. But it's basically a transaction protocol that is based on some ideas from the Bulletproof's range proof protocol that we already had integrated for a separate protocol. And it effectively uses one big single integrated proof for all spending that handles spending, it handles balance, and all of our auxiliary data, all kind of like tied up into this neat, efficient package. It's kind of cool. And the reason I like it is because much like Atlantis, you get very, very small proofs, and you don't even need to kind of migrate over output pools. You can kind of reuse the same data that's already on the chain in terms of decoys in a really, really small, neat way. But the downside is the cost of speed. OmniRing transactions would be slower than we're dealing with right now. And I kind of mentioned something called batching before, where in certain schemes, you can efficiently verify many transactions all at the same time. And right now, you can't do that with OmniRing. So the scaling is really good for space, but it's not very good in terms of time. Everything else about it is pretty great, though, because you'd be able to get large anonymity sets without sacrificing size very much. So right now, I know the team is working on ways to allow basically either batching or kind of separating out some of the inefficient parts in a way that maybe could be batched later. So this one's kind of still very much in progress, but also very promising. And the last big one that came out was called RingCT 3.0. That's called RingCT 3 for short. It is a transaction protocol that at first blush kind of looks like OmniRing. It also uses some ideas from this bulletproof scheme that came out of Stanford, but it's definitely much simpler in structure, and in fact uses separate proofs for spending instead of OmniRing's one compact single proof. So much like OmniRing, though, it would allow for very small spend proofs at fairly high anonymity sets. So the reason I like it is because it can be made efficient through batching, unlike OmniRing right now, but at the cost of some migration stuff that may involve some tricky situations later. Another downside is there are some questions that remain on some of the security proofs that are still being worked on. But much like OmniRing, it's a clever design, small proofs. In theory, it's actually quite efficient if you can batch it. And there is prototype code actually available for this too, and we're still kind of looking into some of the proofs along with some other cryptographers. So, what does this all mean? That was all words. This is a picture. This is a table kind of comparing what I think right now is the current status of a lot of proposed transaction protocols that could allow for different anonymity sets. So with several of these, we can get large anonymity sets, which is good, whereas some of the other ones that we were originally looking at keep them fairly small the way we have them right now. Batching is something we want to be able to do. It means that you can take a bunch of transactions and very quickly and efficiently verify them much more quickly than you could on their own. It's kind of a mixed bag whether or not you can do this. A couple of proposals like Lelantis and RCT3 do let you do this. Whether or not we'd have to do what's called a migration is also important. Migration would mean that you'd effectively have to kind of have a cutoff point for which new transactions must use the new protocol, and you can't use decoys from old transactions. It's not really a game changer whether or not you have to do this, but ideally we would like to not have to do it. And CLSAG and OmniRing are the only ones right now that would not require such a thing. There's some tracing issues with DLSAG and Lelantis that I think are more or less showstoppers unless we can solve them. And finally, some of them do have code available, but that's obviously not a showstopper. My conclusion to this is, despite the fact that we have a lot of really interesting options, as you can see from this table, it's kind of a mixed bag. I don't see there being a definite clear winner at this point that gives us everything we want. You know, high anonymity set, small proofs, efficient proofs, no real downsides. However, I can say that right now, CLSAG, provided it passes audits, which are looking like they will probably be pretty good so far, that definitely will go through as kind of a current drop-in replacement for what we have now. The code's very, very simple, and despite the fact that it doesn't really increase anonymity or allow batching, it doesn't require migration, there is no tracing, we have code for it, and it is more efficient, just slightly though. But I always get asked, what about zero-knowledge stuff? That's surely a thing you want to do, something. So what about ZK Sporks or ZK Snacks or whatever the latest thing is that sounds like that? My motto for all this stuff is that these sorts of things you often hear about, and there's many different instantiations and constructions for things that, you know, involve general zero-knowledge proving systems. Those are proving systems. A proving system basically lets you take certain kinds of mathematical statements and show that they are true or valid in some way without revealing too much information about them. That's a proving system. A proving system is not a transaction protocol. These things are transaction protocols. So they dictate how to take outputs or notes on the chain and spend them and kind of authorize their signing and things like that. These are just proving systems. A proving system is like a language. You effectively have to have something to say in that language. Otherwise, the language itself is not useful. And right now, the most efficient ways that we can do these sorts of general zero-knowledge proving systems are generally require a lot of centralized trust. So the big asset that uses this right now, of course, is Zcash. And the instantiation of ZK Snarks that Zcash uses right now gets a lot of efficiency. So things have become quite fast in Zcash and quite small. But you have to do a deal with the math devil. And the deal with the math devil that you have to do involves centralized trust. And that's something that if you're okay with, you know, great. You get fantastic efficiency, you know, and Zcash does a good job with their transaction protocol on that. But if you're not willing to accept that kind of centralized trust, like I would say most other projects and assets, then you don't really get to use that. And unfortunately, right now, building complete transaction protocols on generalized zero-knowledge proving systems, you have to sacrifice. There are a few trustless ones, but they're just not quite efficient enough. So that's the status of that and why, you know, right now, we can't really move to a generalized ZK system. So it's unfortunate, but hopefully someday we can. So what is actually next? Well, we like to audit and deploy the CLSAG signature scheme, which will make transactions smaller and a little bit faster, which is great. Hopefully try to work on some of the DLSAG and Lelantis tracing issues. Remember, DLSAG could enable things like payment channels, which would be nice. Lelantis would allow for much larger anonymity set sizes. With OmniRing, which is nice because it maintains a lot of kind of Monero similarities, if we can get batching working on that so it's efficient enough, or possibly proof splitting, then it would potentially be a pretty likely candidate to go in as a transaction protocol. And for RCT3, it's really a question right now of kind of making sure that the security proofs on it are nice and solid. But the motto of all this, if you take anything away, should be that transaction protocols are very subtle and they're very, very tricky. That table should have hopefully told you that you don't really get everything for free. While it would be fantastic, I don't think anyone's really fully solved the idea of something that is trustless and efficient in every way. You know, the goal is to try to iterate and get better, and these protocols all definitely do that, but in different ways. So do we have time for questions, folks in the back? We do. Awesome. So I guess if there's any questions on this, I am very happy to answer them, or we could just end early. Yes. Oh, so view key functionality for things like auditing. Right. So Monero, of course, if you were at one of the earlier talks, You basically have two keys. You have a spending key and a viewing key. You can provide the viewing key to, say, an auditor or someone else who you'd like to be able to watch for transactions on your behalf, but they can't spend those transactions. This can be useful for many reasons. Some of these protocols do, in fact, permit that. So, for example, CLSEG and DLSEG would. OmniRing also would. Ring CT3 could also have this enabled, and Volantis, I don't believe, has any such functionality built in. So the answer is mostly. The nice thing is some of these protocols, in fact, they're neatly abstract enough that you can kind of just port over a kind of view key functionality that you would want in a really clean way. Yeah. Yeah, that's a good point. So the question was about, whether or not this whole idea of migration would require users to take action to avoid losing funds. The answer is no, it wouldn't. And I definitely should have clarified that more. So when I say migration, what I mean is that effectively you kind of have a cutoff point, and new transactions would only be able to use members of an anonymity set that were from that new protocol. Whereas if you had old funds, before you could use the new protocol, you basically have to kind of do as a migration transaction to move the funds over to the new pool. I do not think that there would ever be any issue where funds could become unspendable. It would just mean that there's effectively a small added step in there for technical reasons. Ideally, we don't like to do this because ideally you have the anonymity set be as widely available as possible. But no, I don't foresee there being a situation where funds would be unspendable. That's not very good for sound money. Yes. Yeah, and I should say that I'm not the one who makes these decisions. So I build math, and then I tell people if I think the math is good or bad. Yeah, it's I speak only for myself with any of this stuff because I work independently. Well, so, I mean, the Monero project has historically iterated on things as they get better. So picking something and staying with it is, a very, very tall order, and it's not something we've necessarily done. So, for example, moving to CLSEG, I mean, if one of these other protocols, were fantastic and ready right now, I don't think I would even consider CLSEG as a viable option for it. But it's something that is a small enough change at a technical and coding level that it could reasonably be adopted very, very soon, while we sort of work on solving some of the issues with these other protocols. So, is that good for technical debt or bad for technical debt? I mean, you got to make your sacrifices, right? But it's right now, folks seem very excited about CLSEG. So again, I don't make these decisions, but I like it. I think it's good to go. Yes. So for RCT3, I mean, provided that it was shown to be, provided that all the proofs end up working out okay. And again, I should point out too that none of these papers have been peer reviewed. So these are all preprints, which, to be very, very clear, anyone can put a preprint out. Literally anyone. Getting peer review, by the way, is it's more challenging than you expect. So provided that any of these schemes are shown to be sound, and then it's just a matter of what the coding is going to look like. So RCT3 is fairly simple and straightforward. Volantis, slightly less so in comparison, and OmniRing is probably the most complex about all of them. But I mean, if folks were really interested in them and worked hard, that could be on the order of a year, 2 years. But I mean, I'd hesitate to put a number on that because you never know. Yeah, and again, if you're waiting on peer review, who the heck knows? That could be a very long process. Someone's back there, yeah. No, the protocol itself was called CryptoNote, and it was also a pseudonymous paper, kind of akin to how Nakamoto's paper was a pseudonymous paper. Yeah, but I mean, it's a separate code base, but it was kind of migrated over from other assets originally. That just used kind of it was a CryptoNote based code base, yeah, and it's just since been migrated much further than that with other additions. Oh man, CryptoNote was the transaction protocol. CryptoNight was the original proof of work algorithm. Yeah, they're conveniently almost identical names. But again, now Monero protocol has definitely moved far enough away that I would say it has a CryptoNote heritage, but is quite different now. I thought there was another hand there. Sure. Oh, Like, I guess I don't quite follow what you mean. Oh, sure. So like if I added Monero protocol in here right now, oh, I should have done that. Oh man. Right now, I would say anonymity set is quite small, on the order of, and again, it's a network parameter, but on the order of about 10 notes for anonymity. Batchable, it is currently not batchable. Some parts of it involving range proofs are very, very batchable, but signatures are not batchable at all. In terms of migration, there was a sort of a migration when we moved to our confidential transaction model, but it was a pretty clean one. Tracing, as far as we know, does not have any, and of course, we have code for it. There's a question up here first. In what way? I don't really do like a lot of the day-to-day, like in the trenches development. But there's a large number of contributors. I would say, like, if you were to plot out like number of commits per contributor, like there's several folks who do, I would say, the majority of commits, which is probably true for any project. But I would say honestly, right now, a lot of it is getting. I mean, ideally, if we could get more developers who were magically willing to devote large amounts of time, to doing development, be pretty fantastic. But again, like the majority of people who do so just do so because it's an open source project and probably can't devote that much time to it unless you meant something else. Oh, I see. So you're saying like how do you actually encourage people to come in and do such thing? I would say in general, a lot of it just has to do with like what kind of community you choose to build, which is like an ongoing problem, right? I mean, the development in Zcash tends to be very, very centralized. And a lot of what they do ends up being more complicated because their transaction protocol is much more complex. And I don't really have a great answer to that question. Because again, like I don't do a lot of the day-to-day development on this. I do a lot more of the math side. But I think what would be nice is if it were much more clear what small tasks remained open, so that people could kind of have a better sense of like what they might be diving into for a particular problem. And maybe folks aren't very good at doing that right now. So I don't know if that answers your question. And I would say even on the math side, right? Like it's often good to step back and be like, okay, what are some problems that need to be solved right now? Like how neatly contained are they? And what would be like the time and knowledge commitment required to solve them? And it's tough, right? Because no one wants to be the one to maintain that list, which is, I don't want to maintain that list. There was a question in the back, I think, first. Yeah. Becoming a what? Oh, you're talking about like the formalization of it as a protocol. So in terms of like very, very formal protocol analysis, yeah, formal protocol documentation has been like severely lacking for a long time. And there's like steps to try to get at least kind of a bare bones protocol in place. But one of the big problems is that it iterates so quickly. And that, we like even the base stuff that we have right now like needs massive updating. And no one wants to write the documentation. So it's not there yet. I personally would like to see it there, but again, I don't run the show, so. Yeah. So you're talking about how do you determine like what the optimal anonymity set is? Yeah, bigger is better, right? But a lot of and so you're talking about the I want to say complaints that we get because they're valid about the fact that like decoy-based privacy like Monero uses is in many ways inferior to like having a full anonymity set, like something like Zcash has, which in some sense is true. But I also don't want to say that having a full anonymity set is like this magic bullet that solves all your problems. There are all sorts. There's network metadata that floats around. There's other transaction metadata that floats around. Zcash has transaction metadata too. Folks maybe don't talk about it as much, but they do too. But it is absolutely true that like certain kinds of analysis that are possible with decoy-based assets like Monero are because the anonymity set is small. And we don't need that. Anecdotally, I would say like the numbers we've been kind of throwing around are like 2 orders of magnitude differences. So we're at like order O of 10 right now. We're thinking like once you get to like perhaps O of 100, then you start getting a lot of diffusion in your transaction graph that I would estimate would probably reduce the effects of that kind of analysis. But again, that's not the only thing that you have to care about. There's plenty of other metadata that's floating around that's very, very tricky to get rid of. So Dandelion, yes. So in terms of like network level stuff, like kind of the big goal is to be able to allow for much better support for running over Tor, running over I2P, and like running Dandelion style routing. But running Dandelion style routing, where some folks are running over just plain old internet, some folks are running over Tor, and some over I2P, is surprisingly tricky. And we've had some folks who've been looking very, very deeply into doing that. So the plan is to integrate such things. But it has to be done carefully. And again, like running over Tor doesn't magically mean that there's no metadata floating around either. So none of this stuff is a silver bullet. It's very, very layered and very, very complex to integrate properly. Yeah. In your mind, what's something that can take Monero to the next level? What's the next level? I would say like having like something like this, being able to have much more efficient transactions at a much higher anonymity set size. Like, what is that going to do? I don't know. I mean, right now, like it's usable. It's usable right now. But yeah, it's usable right now. But there's plenty of analysis that works on it, right? And it'd be nice to not have that analysis work anymore. Like if one person can do the analysis, any person can do the analysis. And like, I don't want the bad guys being able to do that analysis either and put people in danger. All right. That's plenty of questions. We'll just go ahead and stop. All right. Well, thank you for indulging me in speaking here.